Hello, ladies and gentlemen. Today we're going to be talking about the appropriate uses and the inappropriate or misuses of statistics. So, what you're going to need today is a foldable or your notebook and something to write with, like a pen or a pencil. We are still in the first unit on vocabulary and basics of statistics. So, when it comes to understanding statistics, it's important to ensure that what is being represented is actually accurate. So, when it's all said and done, like once we've collected our data and we've organized our data and now we're presenting our data and our findings, are we actually presenting the accurate findings that we have found as a researcher? Or are we somehow skewing our findings, whether it's intentionally or unintentionally? So, in this foldable lesson today, we're going to be talking about all the ways that are commonly found to misuse statistics. So, in order to use statistics appropriately, obviously you would want to not do the following 6 or 7 misuses of statistics. So, the first one is called suspect samples. And these titles are kind of vague because Mrs. Littlefield is the one that came up with these titles, but these are the types of ways that statistics can be misused. And so there's probably better ways to name these misuses, but this is what I have come across and found in the world of statistics as to how things are misrepresented. So the first thing is if you draw your sample wrong. So suspect samples is like collecting your sample inappropriately. And I'll say badly here. So, like, is your sample size large enough? Like, is studying only 4 people in a building of 2,000 going to be a true representation? No. Or how was your sample selected? Did you not use a good sampling technique when you selected your samples? And then, is the sample actually representative of the population? So maybe you have a good sample size, but you haven't thought of all the different ethnicities in your sample that could represent the population. So, an example, I guess, would be like 3 out of 4 doctors recommend Trident gum, when really, in reality, only 4 doctors were surveyed. That's a example of misusing statistics. Number 2 is faulty survey questions or faulty written questions when you are merely observing and taking answers from people. So, it is really hard to write a unbiased survey question. But here's some examples. Like, do you feel that statistics teachers should get paid higher versus do you favor increasing tuition costs so that colleges can pay statistic teachers higher salaries? Like, are the questions giving you the full picture of what is really happening in order for you to make an informed decision? Or is the question somehow already leading you to a specific answer because of the nature of the question? So, faulty survey questions are questions that are written very poorly. Changing the subject is what I like to call this one, where you have different values that are used to represent the same data. So, different values are used to represent the same data. So, saying a 3% increase versus a $6 million increase, it's the same statistic, but you're just saying it in a different way so that it can have more of a shock factor, more shock factor this way. And then this would be less of a shock factor. So, if we're talking about 3% increase of national debt versus $6 million of increase in national debt, when we put it into perspective with this percentage, 3% is relatively small, but when we hear millions of dollars, our brains, when we hear millions, think that that's like astronomical and huge, when in reality, the perspective is that it was only a 3% increase. So I like to call that changing the subject or using the numbers to your advantage, I guess. You could say that, using numbers to your advantage. To your advantage. So this is a way of showing your bias on what you want readers to pick up on. Like if you want readers to have that shock factor when it's not even there, then you would want to say $6 million increase versus a 3% 10% increase. Okay, detached statistics are when there's no real comparison that can be made. So when it says like, this is a typical like infomercial, I feel like. Okay, so in a typical infomercial, like for Coke, it'd be like, Coke now has a third fewer calories. And these kinds of like infomercial sayings always leave you with like, then what? Compared to what? As to what? Or what did it used to be? Those kinds of things. That's a detached statistic, is that they're not using any kind of comparison when they're saying that it's better or less than, they're assuming than it was before, but they didn't even make the comparison than it was before. So that's a detached statistic or a misuse of a detached statistic. They like to throw numbers in there like has a third fewer calories, but they didn't say then what? Are they saying then the previous Coke recipe, then Diet Coke, then Pepsi, then Dr. Pepper? What are they comparing it to? We don't know. So when there's no comparison to be made, that is a detached statistic example. Implied connections. This is the classic, you guys. This is the classic correlation. Correlation does not mean causation. Oops, causation. Sorry, my handwriting's so poor. But correlation does not mean causation. So in the example that is listed below, they're saying they found a direct correlation between the increased consumption of ice cream and shark attacks. So what they were saying is that this map, if they had number of ice cream sales or consumptions, ice cream sales, and they had shark attacks on one side, a direct correlation is saying that as the ice cream sales went up, so did the shark attacks. They went up. So an implied connection or a correlation that's being drawn here is saying that the more ice cream sales that you have or the more ice cream that you're eating at the beach, the more likely you are to be attacked by a shark, when that is not true. That's not true. So there's some other variables, maybe lurking or confounding, that are happening in this scenario that mean that it's not a causation for this correlation. Like, just because you're eating more ice cream at the beach doesn't mean you're more likely to get attacked by a shark. There's no causation for that. So some more lurking or confounding variables will maybe be like the weather. Like if it's really nice out, more people are at the beach, meaning more people are buying ice cream, meaning there's more people in the water, which means that there's more likely going to be a shark around to bite somebody if there's more people in the water, right? So implied connections mean that there's some sort of correlation that's being claimed between the variables that may not exist, or most of the time does not ever exist. And that little drawing that I wrote right there was the website with the graph on like how it shows ice cream sales and shark attacks. Okay, ambiguous averages. The reason why I say ambiguous means vague, or like we don't know where it's coming from. So what are we saying when we say ambiguous average? So what Littlefield was thinking when she called this misuse of statistics is that in the world of statistics, an average is technically just a measure of central tendency. How you can calculate a measure of central tendency can be actually finding the mean, which we typically call an average. It could also be the median, it could be the mode, or it could be the mid-range. So an ambiguous average is something that we will never know unless we are the researcher ourselves if this was truly calculated as an actual mean. So when they say, like if Verizon or T-Mobile says the average cost of a cell phone bill a month for T-Mobile is, I don't know, $65, they are not telling us if that was the true calculated mean. Like if they took up all their customers and added up all their costs for a given month in the state of North Dakota and then divided them by all the residents that are T-Mobile members, versus like if that's the mode or if that was the median. So what I'm trying to say is if they don't actually specify how the average was calculated, just be cautious of what kind of advertisements are trying to tell you. It may not be the actual calculated mean. A misleading graph is probably one of the number one ways that statistics can be misused. It is so crazy how many graphs can be misleading with so many viewers of those graphs not even catching the reasons why they're misleading. So here's an example of a misleading graph. And what we're looking for is the difference between the X and Y axis scales and appropriation for their, like, are they appropriate for the data that's being represented. So DirecTV is the headline saying DirecTV stomps the competition, and this is what they're showing. So what is so misleading about that? If you need to pause the video, you can to take a better look at the graph. It looks like this DirecTV box is way bigger than the other two. But if we take the mathematical difference between 95 and 81, 95 minus 81 is only 14. What's the difference between 81 to 56? 25. This is a way bigger gap between Dish Network and cable than DirecTV. So what's misleading is that they're trying to make it look that DirecTV is way farther ahead than Dish Network and cable, when really the difference between Dish Network and cable is way, 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 way higher or way larger. It's almost double. So make sure you're watching for scales or axes with appropriate or inappropriate graphs and misleading graphs. That's the number one way, not the only way, but definitely one of the most common ways to mislead a graph is by screwing up the scaling or skipping the scaling or jumping and all that stuff. Okay, so what you're going to do for your homework is you're going to find 2 examples of these ways you can misuse statistics on your own. And then there's some Google Slides for you to fill out when you do these examples. But we will explain this homework assignment more when we are together so we can talk about these 7 different ways to misuse statistics a little more when we come back to class, and then we'll talk a little more on like what the homework will look like. But either way, I hope you took good notes, and I shall see